Hello and welcome to The Local. This is the podcast where it's normally Tim and I who talk about all things crypto markets, trading, all this kind of stuff. But Tim's unfortunately not with us today. But that's great because we've got a guest, Josh from Natively. Thanks for joining us today. How's it going? How was the journey over?
Yeah, been good.
Yeah.
Just coming. Been a long trip. Was here on Sunday, and yeah, it's been
So
all
you're
good.
originally from Texas?
Yeah, Austin, Texas.
Yeah.
Yeah.
We were actually just talking beforehand about how I've been partying in Texas before when I was a young guy. How are you finding it living there? What's the bar scene like? Given we're having the beers,
It's good. I mean, at my age, I don't drink too much anymore. Like a night out is just like the week's gone.
Yeah. I'm not too bad at all. Weeks ago. Do you have like a favorite bar?
Favorite bar? Ooh. Not really.
Really? Because the bar scene is different to the pub scene, right? Because we and Tim and I always have a conversation about like what's your favorite pub? What makes up a good pub?
Yeah.
But I was thinking American bar is kind of different.
We don't have pubs.
Yeah, but I do like the sitting at the bar aspect because the pub you could stand at the bar, but it would be kind of rare to sit at the bar.
I mean, most of the time we just usually grab a drink in the restaurant or whatever.
Okay. It's a fun city though, right?
Yeah, for sure.
Yeah.
I mean, the one thing in Austin that they have is like, I don't think you guys have it here too much, but they like to intermix like beer drinking with other things. So there are like tacos and beer, or like haircut and beer, like weird shit.
Just add beer to anything you do. Driving and beer. No, maybe not actually.
Yoga and beer. They have that too.
Yoga and beer. That's something to do. So, I do remember one time I went to Austin and we went to a thing called Chicken Shit Bingo.
Okay.
So I don't know, there's this bar, right? And they had like a cage with a chicken in. And whole numbers on the floor, and you could bet on which number the chicken was going to shit on, and then it like released the chicken. They'd run around it and do a shit, and then you'd win a drink or whatever if you'd bet on that number.
Dang.
Yeah. It was
That's
super
crazy.
Fun. That was super fun. We're both technical founders, right?
Yeah.
So why don't you tell me? I actually don't know. So why don't you tell me a little bit about your background?
Back in school, I think I was most interested in like low level programming. So
Okay.
I come like from kernel operating system stuff.
Okay, all right.
So yeah, I really liked to muck around the low level stuff that's close to the hardware.
Right, okay, so are you talking about like writing in assembly language or actually thinking about the operations that the CPU's running? Like where are we talking when you say like
Yeah, sometimes assembly language,
Yeah.
like if you're writing operating systems, you'll need to write at that level. But usually if you can avoid it, I'll do like C
C
stuff.
is that what you're still writing now in C or
No, Rust now.
Nice.
I think Rust is kind of taken over.
I've become
the stuff C is done.
Yeah, I've become an absolute Rust maximalist.
Yeah, you like it?
Oh, I love it. I actually find it like super productive now, particularly as our like system, I think we're probably in 10 million lines of code or something like that. It's like quite a large system as you go with diverse libraries and binaries and all this kind of stuff. And I do think that it like the fearless sort of like refactoring that you can do because of like how nice the type system is, having some types is so nice. You got any particular crates that are your favorite?
I mean, with crates, not so much. I don't know too much, but I think the thing about Rust I really like is like with C, you always had to worry about like memory allocation.
Yeah,
I don't know if you've worked with C at all.
Yeah, well, so I did a little bit of C. So when I did my PhD in fluid mechanics, and so I used C. I did it like computational fluid mechanics.
Yeah.
So I used C to solve the Navier-Stokes equations with like a finite difference scheme.
Sure.
It's sort of like doing a lot of matrix calculations.
Yeah.
And obviously C was quite well. There was one program that existed before I got that was written in Fortran, which I was like, I'm not going to use that. So I did a little bit of C, but it was a long time ago now.
But yeah, if you're doing like more matrix stuff, you're going to need high performance stuff, low level stuff.
I was like running stuff on like the big supercomputer. So I was using like 5,000 cores. Something like that, and like you would like schedule the job to run, and you would get time on the big machine. Yeah, because it might take 2 weeks for your simulation to run.
Right.
You hope that you didn't have a bug.
Yeah.
Because you're not getting that time back to run these like big high dimensional, like not really high dimensional, sorry, 3-dimensional simulations.
Right. Yeah.
But yeah, so when you were saying it, so there's a difference the difference in C versus Rust. In terms of memory allocation.
It's just like with memory out, like that was for me like as a kernel or low level developer, like knowing where all these memory allocations are, managing that was always such a big pain. And it's usually the biggest source of bugs. Yeah. But the fact that with Rust that you can like remove that without even really thinking about it.
It's like embedded into the way that, the borrow checker and embedded into the way that the language is like designed, with everything getting dropped.
Exactly.
I really love it. We are nerding out too much though, right? I think actually, I think with the viewership
I think we could keep on going.
Yeah, the viewership of the podcast has gone to like 20%. So let's talk a little bit more about like your shift from okay, so you're an engineer, same as me. I don't know if I consider myself an engineer, but I do write Rust 50% of the time. How have you found that like transition to like being a founder and like the business aspect of things? So like maybe talk to me a little bit about actually like so you started out as an engineer, you worked at a few different places, right?
Yeah, worked mostly being a software engineer. And then I guess the transition to founder, it's just different problem sets. You have to think a little bit more out of the box. I think with being an engineer, like the criteria for success is a lot easier. Whereas as a founder, you don't know really a lot of the time if you're doing the right thing or the wrong thing. So I think that's been like the biggest difference, as well as doing things like podcasts.
You never think when you're like sitting in your like writing code at 11 a.m. being like, I'm gonna have a podcast next week actually.
Exactly.
So actually, tell me your actual path, right? So where you went to university?
CMU, Carnegie Mellon.
Okay, nice.
So I was there, graduated there maybe 2009, and after that worked at NVIDIA.
Oh yeah, cool. What were you doing? Obviously that's 2009. It's not quite the same company as it is now. What were you?
I wish I held all my shares.
You might not need to found a company then.
Exactly.
You'd have been out yacht shopping anyway, right? So 2009. So were you working still in graphics card development stuff there? CUDA wasn't a thing then.
CUDA was a thing.
Well, CUDA was a thing.
Yeah, CUDA was a thing. They were like kind of beginning that stuff. You probably know that from your fluid dynamic stuff, right?
Yeah, there were obviously lots of pushes to parallelize stuff, but one of the issues is, without boring people, is like you actually have like transfer of information across the elements. Yeah, and so it's not actually a massively parallelizable problem because there's interaction between. Anyway, I won't get to it, but there's interaction between
You've got dependencies and serialization.
Yeah, exactly. Because if you think about it, there's actually like an advection term. And anyway, I won't get into the boring details. But actually, I was using CPU. I don't know what the state of the art is these days. I've been out of the game for 10 years or whatever. You know what I mean? So maybe people have like made breakthroughs with GPUs, but certainly at the time when I was doing my computational fluid dynamics, I was using CPU bound stuff. But sorry, you were saying, so were you working on CUDA or no?
No, I wasn't on the CUDA team. I was more on the software driver team. So all GPUs have like drivers.
Yeah, of course. I'm a Linux user and I'm always cursing the NVIDIA drivers.
NVIDIA drivers are like the fuck you from lettuce.
Like what is it? Just that they just don't want to support from like commercial reasons, or like what's the, because it's like hand rolled by the community, right? Isn't it? How the NVIDIA drivers, they're not official on Linux, or maybe they are now.
No, I think they've always been closed source, which is like the big. There's like an open source version, but it's not as good as the closed source. But like if any bugs come on, it's like you're gonna have to wait for NVIDIA to fix it or whatever. So it's like that's always been a source of conflict. But anyway, I worked on more of the drivers part, because like GPU is such like it's like another piece of hardware that needs to be managed. So basically, I worked on the team that managed like the resources on that GPU. So if you think of like the operating system as the thing that manages the CPU, I worked on the team that worked on the software that managed the GPU.
Okay, makes sense. So from a kernel perspective, or like higher up.
From a kernel perspective.
There's not like a user space sort of thing or anything.
Okay,
that makes sense. Okay, that's cool. How long were you there for?
I was there for 2 years.
Okay. So a bit like in and out. What was it? You fancy doing something different?
Well, it was like I loved like the project I worked on was like amazing. So I did like virtualization of the GPU.
Okay.
Which is like another crazy complexity stuff, and I loved it. I think for me, it was just like NVIDIA still is kind of based in Santa Clara, which is like this small, not really small now, but it's not like a big city. I was in my early 20s. I kind of wanted to
go out and party,
have fun, meet people
and stuff. Yeah.
It was more like a family town.
Okay.
And NVIDIA was like super stable. So after that, I went out, worked at a startup called Metromile.
Okay.
Which is, they were in another city back then, but then they moved to San Francisco. So I got to move to the city, kind of working in much more like risky type business.
What were you doing in Metromile? What's the vibe?
They were one of the first. I think they were the first. I should know this, but they were the first per mile car insurance. So like basically, every mile you paid, it was how much you'd pay for insurance.
Okay, it's kind of like I suppose like the more you drive, the higher the risk, right?
Yeah,
so
exactly.
It's not a bad way of pricing.
That was the idea.
Yeah. Because that's not. Did that take off in the US? I don't know what the insurance model is like over there, but did it take off?
I think they did pretty good. They got bought up by Lemonade. I don't know if you've heard of them.
I don't know.
Lemonade is like a bigger kind of insurance company that does all types of insurance.
Right. Okay.
I don't know where they're at now.
Yeah, because insurtech is like an interesting space, I always think, because it's like quite an old school industry. Like, total aside, like we were getting some insurance for our business that we needed, and like obviously it's huge insurance in London, right? Lloyd's of London, like sort of this, and the trope is that the guys are just in the pub, you know, like
oh really?
Yeah. It's like old school city boy kind of way, not like a technical guys. And literally, no word of a lie, we had to ring this insurance guy up, and he was in the pub. We rang him up, and I'm like, "Come on, man, you are literally playing into the stereotype." And he just went, "It's going to be like, however much it was, 10 grand or something, 20 grand."
I mean, I guess for the business, right? It's like once you have your insurance business up, you're just like,
it's just like I'm like, who's underwriting this? Who's just making this up, man? Like, where did you go after that?
Kind of following my like 20s thing, I kind of just traveled the world after.
Oh, fun!
Working there.
That's chill. Where do you enjoy going?
I went to like Southeast Asia.
Okay, yeah,
kind of met my wife actually
out
there.
Oh yeah.
But then after that, I think the crypto kind of. I think this was like 2017. Crypto was kind of
ETH has been out for years. The ICO era, right? And
And I've always heard of like Bitcoin in the background.
Yeah. You hadn't like got dabbled with Bitcoin on the Silk Road like I had.
Yeah. No. Yeah.
I was just buying flowers.
Of course. Very legal flowers.
Very legal flowers. There's different type. Now, it's like you don't need it anymore in the in Texas, actually, you probably do, right? It's still illegal in Texas, right?
Well.
Or is it medical?
I don't know.
Is it medical all right now?
It's a big gray area. Like, for example, they sell Delta-9 in farmers markets.
Okay. So
I don't even know what the real law is right now.
It's my view of Texas is like we're conservative, but I guess maybe like the whole space.
Well, they're conservative, but they're also like freedom type thing. So it's like
how does that come in? Yeah. You should be allowed to do that, but I'm going to judge you for doing it.
Yeah, exactly. One of the reasons why I started traveling was like I didn't really find any work too interesting because I come from that low level background. Right?
Yeah.
And what I always found interesting about software is like, managing resources when there's not much available. That's essentially what a kernel does. Right?
Yeah. Right. Okay. And so you like this idea of like being really constrained in the amount of memory that you can use. And,
exactly.
Yeah. Okay.
And kind of dealing with that. But back in 2010s, most of the startups were dealing with like Web 2 stuff, new things, social, like apps.
Yeah. And it's like, who cares? Like
it's applications.
Yeah. It's just like, who cares if it's 200 milliseconds latency or like whatever, man. Yeah.
Or at the same time, like those problems have been solved.
Yeah.
You've got like a cloud infrastructure that kind of does all that stuff for you already.
Yeah.
And so like I did some of that stuff, but it was like not very stimulating, not very interesting.
Mm-hmm.
But then when I like looked into blockchain, it was like these old problems that I was really interested in started becoming interesting again.
Yeah, right.
Like because you've got a blockchain, which is like
you have a finite amount of
things.
transactions.
Yeah.
Block space is a premium.
Yeah. Slow.
Yeah.
You've got security. It's a distributed system that needs security.
Yeah.
So like that like really kind of got me into that space.
And were you ever trading? Were you ever punting any coins? In this 2017 bull run? Because I feel like everyone has to kind of like get a little taste for the volatility as well.
Yeah.
I think like humans, we're kind of like we're natural gamblers, right? Like we just like look at a horizon, and go, yeah, let's go over there. I'm sure it's fine.
Yeah.
And so I kind of like. I actually like kind of just did the punting first and never and I don't know if I ever really drank the Kool-Aid on the tech until maybe 2020 actually, because I was a bit like, it's cool and whatnot, but I was never really. I'm a bit of a shameless capitalist, right? So the kind of like the original sort of like the cyberpunk kind of like
those were the fun days, like when it was like that cyberpunk feel.
Yeah, but I was never really like that guy. I'm not like I'm not so much like fuck the man such sort of thing. But yeah, like I didn't kind of get a handle on like the possibilities of the decentralized tech until like once once you start having decentralized compute, like decentralized store of value, you know, like what Bitcoin is one thing, but once you start decentralized compute, then you can start. That is actually quite an interesting improvement, I guess, or like innovation, if you will.
Right, for sure.
Did you start developing on-chain stuff, or
not too much? Well, actually, like my journey into this kind of the opposite. So I really kind of got into the tech first,
right? Okay.
And then kind of grew a love for like the finance stuff,
the
crazy stuff.
Right?
So
okay, yeah.
Kind of the inverse.
You did it opposite of what I did. Yeah.
But I've always been like really interested in like game theory, finance. I'm a big like Nassim Taleb fan.
Oh, really?
Yeah.
He's quite controversial on the internet now.
Oh,
right?
yeah.
Don't you think?
Well, he's always
he's always been controversial, but I've seen some like fairly what's the word I would use? Robust rebuttals of some of his statistical analysis. Yeah. Actually, that that he might misinterpret some things. I'm like, I can't think to my mind what it is now, but I'm always if Taleb's out and then people are like, then it's going to be people are going to be either all for it or all against it. And
he definitely causes that kind of split for sure.
Yeah, he's no shrinking violet. Let's put it that way.
So I think like because of like all that volatility and stuff, it kind of piqued my interest even more into like crypto.
Yeah, so you hadn't like no finance
back then. And I started trying all these really shady exchanges.
I mean, I think Cryptopia.nz still owe me about $2,000. Because I mean, like you always think it's going to be different this time, and then like because I kind of remember the Mt. Gox days. That was a big hack, and then like you had 2017. It was like Cryptopia was the one I think that went down.
Cryptopedia was.
I can't even remember. I found the most reliable thing was to actually use local bitcoins, and it's like an OTC kind of thing, but you pay a huge spread. But yeah, and then every cycle, there's always a big exchange that goes down. Maybe I don't know if we've like gone through that now, like this, like but maybe we'll have another one.
We'll see.
Yeah, we'll see. I'm looking at U.M.C. But yeah, okay. So you kind of got into the finance thing.
Yeah.
But you weren't doing it for work then, or?
Yeah. So back then, no, not too much. I was just sort of playing around, trying to play the game, even though it was like I was just starting. But then, I was also looking for a job then, kind of in crypto, kind of get myself even more into the space.
Yeah.
And I was also looking for like a remote job, and Radix was one of the first ones that I saw.
Right. Okay.
And so that's essentially where I started.
Right. Okay. And then what you were doing, like blockchain engineering stuff there, or?
Yeah, exactly. Yeah. So while I was there, I worked on like Consensus. Okay. So back then it was like wide open green space. Like nobody had too many papers. We were still trying to figure out what is this thing, what is proof of work, what is proof of stake wasn't even a thing.
Yeah. The proof of stake has always, my understanding has always been, because ultimately it's Byzantine generals problem, isn't it?
Yeah.
And I always, the mathematical theory behind that has been, has kind of existed for some time.
Yeah.
But so I think proof of stake as a concept was there, but obviously proof of work is the one that Satoshi kind of like pushed first, right?
I think proof of work it was definitely like a computer science novelty.
Yeah.
As in like the Byzantine generals problem was there, but nobody's really integrated economics into it.
Yeah, that was kind of the innovation,
which is kind of where it got in. Yeah, and I think after that, and after seeing like how you could do this with proof of work, then there was like a ton of research coming into like how can we make proof of stake work, and that's where like a lot more research went into the Byzantine generals problem. And a lot more. You see even today, like there's a lot more research done being on BFTs in general.
Yeah, of course. Yeah. I think it's definitely it's just more efficient, isn't it? Because I mean, like proof of work's cool, but like also it's not. I don't think it's maybe I'm I've got like a philosophical idea that we have always got this trend to efficiency,
Yeah.
right? Like over time, we're going to trend down on the amount of like energy that we burn and all this kind of stuff. And so like needlessly spinning CPU cycles to try and find hashes that start with how many? I think I can't remember how many zeros they're looking for at the start of the hash.
Yeah,
it is obviously not the correct way to solve that problem, right? But getting the economic value in might be, certainly more of an efficient. It's more efficient solution.
Yeah, I think it's a little bit. There's. I think there's some nuance there with like with like proof of work where it's like that's like a very kind of brute force-ish way of doing things. But
it's like you can always do things order n squared, but it's better to find the order n algorithm. Yeah, do you know what I mean?
But there is trade-offs you do to get to that O of n.
Yeah.
I think like what we've done. I think it's interesting. Like humans always like. We humans, but like we always like add some level of abstraction or virtualizations to things. Like money is kind of a virtualization of ownership or like
or value or
something like that.
Yeah.
Proof of stake is kind of similar, where it's like kind of virtualized proof of work. So you can add that layer of virtualization on top of like work that's been done and get rid of a bunch of stuff we don't need. But there is like that trade-off.
This is why we're all naturally mathematicians, right? We just want to generalize.
We
just want to find like we have like a desire. Some people we've got a desire to find what the deep connections are in the. It's just pattern matching in a way, right? But it's like
simplify things by having another
having a layer above. Exactly.
Exactly.
And then you find out about ERDOS and you're like, oh, we actually can't do it.
What's ERDOS?
This is very nerdy. I don't know if this will make it to the podcast, but there's this thing called the incompleteness theorem. So it's this idea that to fully explain a system, suppose you have a system with a set of axioms, you can't prove or explain everything about that system with those set of axioms. You need like a higher system. So, for example, say the operations of addition and subtraction. You can't explain everything with the natural numbers. You need to extend to the integers to deal with the fact that you can end up with negative numbers, right? All right, and the same sort of thing like if we introduce like multiplication and square roots and other operations, you then need the complex numbers to describe them. You always need like this something more. So with set of operations, so he can actually show that with the set of axioms that we accept as mathematics, so I think there's about 9 or something like that, Pino's axioms plus I think the axiom of choice, and these are the kind of things that we use as building blocks. So some of them are obvious.
So all proofs can be derived from those.
Oh yeah, exactly right. Exactly. Apart from they can't. He proved that there are things that we can't know given this set of axioms.
Okay.
So like for example, we don't know if it's ever Riemann hypothesis or something like that, some big outstanding mathematical problem we don't know. One of these millennium problems. We can't. It might not actually be possible to prove with the set of axioms that we've got. And one of the axioms that we might have to introduce in the future is the Riemann hypothesis is true.
Okay.
As like because we don't actually with the stuff that we have, we don't prove it, right?
Is it? I mean, it's not the same, but maybe it's the kind of same feeling as the halting problem.
It's one of those things. It's kind of like you can construct this like paradox, sort of thing. It's exactly the kind of idea of the halting problem. It's like you put this set of rules in place, and then you reach this like natural paradox that it can't be explained without something else, without some Deus Ex Machina or whatever. It's interesting that the halting problem is rearing its head with all of these agenetic.
Oh, are they?
Yeah, because basically, imagine you want like some agenetic AI to kind of like go and do something and maybe run some code and whatnot. Well, like, how can the AI ever know that if it's like you're trying to do something in a REPL language, right? Like Python or something. How can it know that the input stopped? How can it know how long to wait for an answer to the problem? Like, because it's an AI, right? So like, you in effect can actually like, it becomes a halting problem. Like, how can the AI know when it's actually going to complete the things so it can go to the next task?
Right.
So there's I've seen some interesting papers where like, you can kind of like get approximations to the halting problem. Or they're trying to approximate when you can determine that this is true, so that they can like have these agents make progress. I see. It's like a mad kind of like like computer science thing, but very, very cool. You get into blockchain, you get into consensus. you're working for somebody else's project.
Yeah.
Are you founding the project your next big thing then?
So with Radix, I was there for maybe like 7 years, which is like eternity in crypto space.
Yeah.
So while there, like I worked on consensus, worked on also building like a novel VM, specifically for DeFi.
Okay, yeah.
And after that, now we're working on start to build this new company natively.
Right. Okay. Did you do that from within Radix then?
No, this is after Radix.
After, yeah. Okay. What's the problem that you've identified then for natively?
So after we built like Radix, actually me and some of my co-founders, we did a bunch of trading as well while we're there, and Radix never really took off, and we kind of saw the problems of that, and also saw some of the problems we found while we were trading DeFi and stuff. And so a lot of this was like, how do we move assets from one chain to another? How do we...
without going via a centralized exchange, right?
Without centralized exchange. So we actually were looking to build an order book first. It was our initial project, but then we found that to have a order book similar to a centralized exchange, we would need to be able to bridge assets into this order book. And we found that this in itself was a really hard problem. Like nobody's really solved that part too much. And so we've really kind of focused more on that part. And so now we're really working on being this interoperable layer where we make it very easy for anybody to be able to deposit assets from anywhere, wherever there are, they're coming from, into whatever protocol they want to get into.
Right. Okay. So it's a bridge technology. Interoperability is the kind of is the real paradigm sort of thing.
Yeah. So I mean, bridging I think is the first part, but then we also found that, as we were kind of building this out, there is this even bigger space, like with onboarding and stuff, where once you bridge, what are the things you want to do? For example, I can bridge into a DApp, a lending DApp, but then I still need to get the gas tokens. I still need to get all these other things to actually use the network, to use DeFi. And I think there's a lot of space there where we can help so that you don't need to get a gas token. You don't need to download a new wallet. Essentially, the idea is that there's a deposit address where you can deposit your assets, and that's it.
All right. So basically, it's kind of like not like an omni-chain sort of thing, but like I can deposit. Let's say I've got ETH on Ethereum. I can deposit to this wallet address, and that enables me to use that ETH on any protocol that I want to use.
It's more like whatever that deposit address has, it encodes everything you want to do. Okay. So I want to add ETH as collateral, borrow USDC from it. Here's the deposit address to do it. Here's the USDC. I'm going to give the protocol the USDC where I want to receive that USDC from.
Okay.
That gives me a deposit address. Anytime I deposit into that deposit address, I'll get whatever.
So like the address is like a little program.
It's essentially, yeah,
exactly. Okay, so you've encoded a program into the address.
Yeah,
exactly. Okay, that makes sense. Yeah.
And so what this allows us to do is like, because all wallets, all centralized exchanges, everybody needs to know how to transfer between deposit addresses. Now you've really opened up all DeFi protocols from every wallet in one step. All you need to do is deposit here, and then you can get access to
right. Okay, I see. So it's like a address as a service sort of thing. Like you encode like and so is that like, can people write these sort of like steps that they want to take and then encode it, or is that just something that you do? Is it like free for the users to write, or do you just provide a set of addresses that do certain things?
What you can do is quite small, so we're going to kind of hard code that. So
you got a wall before you can run, right?
Yeah, exactly. Yeah. So like we're initially going to be focused on like bridging. So like Bitcoin bridging is one of the hardest things to do right now. To different protocols. So. Here's a deposit address. You deposit here, you're going to get a synthetic Bitcoin on this network that you can use.
Wrapped Bitcoin or whatever.
Exactly.
Yeah.
But then expanding on that, developers will be able to encode any type of logic into that.
Okay.
And the difference with like smart contracts is that script or that program is that you can call other networks, cross-chain networks. Right, and then it's also more like you could also do things like it's more of like a script, a cron job.
You
could add like wait times or that sort of thing. So it's much more active.
Yeah, like call this address, then wait 2 hours, then do this, and then and then you encode that in, and then that gives you an address that you then send the assets to execute that.
Yeah, exactly.
That makes sense.
And then at the end of it, send all the whatever assets you got back to the user when they're done.
Right. Okay. And so from a technical perspective, then, like, what's the architecture like from your side? Like, is it a chain itself that you've deployed, or like, I'm trying to understand like where it lives, maybe.
Yeah.
Have you got validators? Have you got nodes? Like, give me like a bit of an explanation about the architecture.
So we are a layer 1.
Yeah. Okay.
And essentially, it's a bunch of validators which agree to the things that have been deposited. And essentially, they are also the guardians of the assets that have been sent. Once those validators have agreed that assets have been sent to them, they're able to then execute on that. So, for example, with Bitcoin, we have an address. Bitcoin comes into an address. The validators see that that's come in. Encoded in that address is the fact that they want to mint onto this network. So then the validators agree to create a transaction that they're going to execute on this other network that'll mint that.
Okay, I see. So they actually have like RPC nodes for the other networks inside them and this kind of stuff. They have all of these like sort of like what you need to be able to interact with other networks, like it's RPC basically, isn't it? But like, okay, that makes sense. That makes sense to me. Yeah. And then, so what's your philosophy on how decentralized it is? Like, how many validators have you got? Like, is the predominant amount of your work improving the node itself and all the logic that exists within that? Is that like what you're working on each day, like the binary that runs on the machine that's a validator? Yeah,
I mean, a lot of it is that. A lot of it is also. To answer the first question, we're looking at maybe like in the tens, the number of validators. And then so there are quite a few tracks technically wise that we're working on. So one is like making it more secure. And so one way to do that is to have more validators. So with like collusion risk, one way you could do that is just increasing the number of validators. Another one is separating out for each, essentially splitting out who the guardians are for each vault. Another one that we're really looking deeply into is using TEEs, if you've heard of them.
These are these enclave things.
Yeah, exactly.
Yeah. So we have some experience. So we're on market making sort of platforms. So one that I know is CoinWatch. And so this is kind of like the way it works is like projects want a market maker. They go through CoinWatch, who kind of like go and source the best deal for that's appropriate, and then actually the market maker provides their orders and trades into this TEE, which runs a piece of code which kind of like summarizes it and then gives it to the user. And so it's this like, because there's this kind of like tension that you don't want to give your proprietary order information out to people, right? So it goes into the TEE to sort of. We can all agree that the code that the TEE executes is, not doing any, isn't sending our order out to anyone nefarious, and it calculates the averages or whatever in the correct way. Yeah, it's like a validation thing, and then like this. So you basically the enclave runs this piece of code that allows to give comfort to the market maker that, hey, like I can give my proprietary information and it's not going to get out, and then obviously gives the user then the access to the information that some market makers might not give. So that's how I've seen these TEs used.
Right. So I think TEs provide several properties. In your case, it sounds like it's more of the confidential property. Yeah. Be able to hide information and provably hide that nobody else can know
provably hide it. Yeah, exactly.
And that's definitely an interesting part of it that we would also use. The other part is also the integrity. So like if we know that this TEE, let's say, for example, running a full node on this TEE, then I know I'll only sign this particular thing if something occurred on Arbitrum network, for example. I can provably do that. And now collusion is no longer a risk, because even if you've got collusion amongst validators, they can't sign a transaction stealing some funds without the TE kind of executing in some way. You know what I mean?
I understand. I understand. It's all done via equality in hashes, right? Is basically what actually happens in the end. The way it's in the ET, is basically like
as in the code that's running on there.
It's like a binary that you can actually then prove a big show that this hash is like the binary that actually ran this particular thing. Is like how I've seen it used. So I can see there's a lot of.
I mean, it's similar to like Ethereum, except in this case, it's like non-deterministic compute. That's whatever's running, right?
Yeah.
Whereas
exactly. With Ethereum, it's designed by the EVM.
Yeah.
Says, I suppose it's
because with the EVM, it's like a single-threaded machine, essentially, right?
It just goes through the opcodes, right? Have you ever built the EVM from scratch?
No. I'm actually not too familiar with EVM.
It was a great learning experience for me. So basically, like, I rebuilt the EVM in Python. So it's just because it's just like you can actually take the yellow paper, and it's just like a stack-based machine, right? So you can literally just have like a list, and you can essentially just like push and pop from this list,
right?
And it's just particular opcodes,
right?
So the smart contract logic just gets like compiled down into these bytes, which are just opcodes. Push this value on the stack, pop this value from the stack, add these two things together.
Yeah.
So yeah, I found it a very interesting experience to do that, like valuable for me in a way to like really, really get to the understanding of like what's going on here.
Oh yeah, for sure.
It's actually quite just a simple VM.
Yeah,
That's all it is.
Super simple. Like a very small, limited opcodes
I basically wrote them by hand. I mean, in Python, just to like to get used to it, and like basically gas is just each opcode has got a certain amount of gas associated with it, and that's how the gas is calculated for running your smart contract.
Right. And I mean, it has to be simple, right? If I guess based on their philosophy, it's like they want multiple clients to be able to execute this thing, different implementations. In order for that to work, you need a very simple one that everybody knows how to follow. Whereas for things with real hardware x86, it's so complicated. Nobody.
No one knows how to. I mean, the amount of instruction set there is insane, right? So it's like it's completely. But it's kind of like there's an equivalent there with the TE thing, though, right? You're kind of like provably showing that these same operations happened. I guess maybe is my way of thinking about it.
Exactly, but like it can execute on like real hardware.
Exactly.
But you know exactly the software that's running on it.
Yeah, exactly.
And it doesn't need to be. It doesn't need to have all the constraints.
You don't have this virtualized sort of like sandbox sort of small environment, right? You can actually just run whatever that a real computer can allow you to do,
right?
Which allows
and it could be
so much more scope with what you can do, right? Because you actually get proper full compute rather than a subset of compute.
Yeah. And it could be. I think the big thing is like it could be non-deterministic, and because it can be
asynchronous, it can be anything, right?
So you've got tons of threads and all that.
Exactly. That's very cool. You've not launched yet, right?
No, not launched yet.
When testnet going to be out?
We're looking to launch testnet end of the month.
Okay.
Q3.
How many guys are you at the moment?
Just three of us.
I remember when we were three.
Yeah.
It was fun. It was like fun, scrappy times because we started out just three. Like building for a year.
Yeah.
Put something out there, and then going out and doing the whole VC thing and like getting backing. Is that like a plan of yours to do that?
Oh yeah, for sure. I mean, we're trying to do all this. Oh man, that beer.
He poured his beer really, really badly, and then I made him down it.
We're trying to do a raise. We're launching a testnet. I mean, you probably know, like in the beginning stages of the company, there's just all these things you need to do to get all your ducks in a row.
Oh yeah, but so many, like even still now, we're like 14 people.
Yeah.
Even still now, we've only just hired like an operations person to because when you start a company, you've kind of got to give the tax man all the details. You've got the accountant calls you up, man, and you're like, I'm trying to write code here, but I also need to kind of like fill the company taxes in or like do the office rental agreement and all this kind of stuff. And like it actually takes so we've done 2 raises, like pre-seed and seed, and then we've got 14 people, and it's only really just now that like
you could do the CTO.
It's like peeling back the ops stuff is happening now.
Yeah.
You know, where it's actually like, I don't know if it's, I wouldn't consider that it's like the tradition to be a proper company.
Yeah.
You know, sort of like where it's not, it's kind of loses its fun in a way where it's like, oh no, this is like serious and like we've got processes and all the things that you start a company not to have. You know, particularly if you're, I don't know what you're like, but like I was never like a big company bank guy, you know what I mean? I always was like, I always found like the compliance and like the like onboarding and all this like stuff like really onerous.
Yeah.
I'm like, I just want to write code and think about problems.
Yeah.
And so when you start a company, you can't just write code and think about problems. And then it comes to you though, right? Like when you grow the company, all of a sudden, oh, like this stuff that I kind of wanted to get away from, you can see how it creeps in.
Yeah.
Lawyers, compliance.
For sure. Those things are like more important than like the code at some points, which is kind of frustrating.
Yeah,
a little bit
frustrating because you're like, I just want to build the product, right?
Yeah.
But also like a necessary evil of living in, you know, a democratic like Western society, right? I suppose is the real things. Testnet's going live this month. Like, where are you going to be at in a year's time? Like, when's mainnet going to be? What's your like goals with the testnet? Is it to use it as an MVP to raise? Is it to get some users to use it? What's your goal?
So with the testnet, we're really looking to really test out the tech because it's starting out as a bridge. It's there's a lot of security concerns.
Well, bridges are classically where the hacks have been, right?
Exactly.
Was there a wormhole one for like $600 million or something?
I think there's wormhole, Ronin.
Yeah, Ronin.
When we started this, like there's a list. We gathered all the bridge hacks that have happened past few years, and there's a lot.
Have you identified then weak spots and imbued defenses into that, like into your tech?
Yeah, definitely. I mean, one of the, I think there are like two main security issues with that hacks have come from multi-sig bridges, where the keys have been stolen or people have essentially colluded to steal those funds. So against that, we basically have a more like a threshold signature as opposed to multi-sig. That allows us to have more validators and prevent that sort of thing. And the other one is smart contract risk, where bridges which are dependent on smart contracts and having those smart contracts be absolutely foolproof to prove that the bridge is correct or not. Yeah, many millions have been stolen that way if there's a bug in there. But in our model, basically, we don't use we don't go down the smart contract route.
What's your alternative to that then?
It's essentially the threshold signature.
Right.
route.
Okay. Right.
So it's essentially holding. So the proof based bridge are based on smart contracts holding the assets.
Yeah.
In our case, it's the threshold signature is the one that are holding the assets.
For the purpose of the listeners, and definitely not for me, can you explain to me exactly precisely what you mean by threshold signature?
So threshold signature is a way for multiple people, multiple independent entities to come together to sign a signature for some transaction. So if you can think of like Bitcoin, that's if I want to send something to you, I would sign that with a signature. With the threshold signatures, I could own Bitcoin with my two other co-founders, and for us to essentially send to you, we would all need to gather together, sign this thing together to be able to send that to you.
Right. Okay. So rather than multi-sig where I sign, I pass it to you, you sign, pass it to someone else, and they sign, you actually have to come together to sign. It's like slightly different.
Exactly. So with multi-sig, it's kind of a different layer of abstraction. So with multi-sig, you have three different signatures. Let's say like, they're us three co-founders. We need to do three different signatures to send that to you.
Yeah.
With threshold signatures, we would need to come together and through some protocol, we would exchange information, then create one signature.
Yes. Okay. I see.
And send to you.
Have you developed? Is this an off-the-shelf thing with threshold signature? Is it like a open source piece of kit out there, or have you actually developed that?
It's a open source thing, and it's something that's just been kind of relatively recently been more stabilized. So it's been around for maybe I'd say 3 or 4 years.
Right. Okay. I see.
But it's been out in the wild more often now, and so like. At this point, we're looking to take advantage of that and push the envelope on that.
So is that one of the USPs of Natively is that it's using this threshold signature mechanism? Maybe USP is the wrong word. But sort of like one of the defining characteristics.
Yeah, exactly.
Yeah.
Because with a signature, you can do any all networks work on signatures, all transactions.
Yeah, of course.
And so with that in mind, we can like really push the envelope on like what we could do with a decentralized network, being able to submit anything on any network using threshold signatures.
It's super exciting.
Yeah.
If natively absolutely rips, and you get the kind of adoption that you want, what's it going to allow you to do apart from buy yourself a new yacht? Presuming you're going to like launch a token and this kind of stuff.
Right. Yeah, I mean, we're really looking to be able to. I mean, one of our like missions is to really get any user wherever they are to really to be able to access DeFi. I think there's so much potential in DeFi that's sort of untapped right now.
Yeah, the UI experience is so shit. I remember like a meme that I saw at ETH.CC maybe last year where it was like, you got to get it, you got to get ETH, you got to do this thing, you got to install MetaMask, you got to do this, and it's like 8 steps to be able to like buy some coin on Arbitrum.
Exactly.
The UX experience and for new users, it's just like terrifying, right?
You don't even know where to start. As an experienced user, like I don't know where to start. As somebody like deep into the space, like
so I'll tell you a real story, right? It's a real story. We got an airdrop. I think it might have been Sui. We got an airdrop for some work that we've been doing with one of the oracles. You had like 7 guys who know crypto really, really well. And it was like, oh my God, like I got to get a little, so we had like, you had to get like a little bit of Solana to like bridge the Sui to like get the thing. And I was like, it's like, we were genuinely like having like competitions about who can actually claim this airdrop because you need to get Sui on the Sui network without using a centralized exchange, right? You need to get Sui, like how that was like. Yeah. You could use a centralized exchange and just extract it, but like, can you get Sui on the Sui network without using a SEX?
Right.
It was impossible. I ended up just like trading some ETH on Binance and like withdrawing it, and it's like, is that what it's got to be like? That's the problem you're trying to solve, right?
Exactly. So it's like we're building this sort of layer on top of all of DeFi, so that all of DeFi is accessible to anybody via deposit address. Deposit address is accessible by pretty much anybody.
Do they accept fiat? Would that be something that would be like on your long-term roadmap?
Maybe, but it's not really something we're really focused on right now.
Okay.
We're really
so you still need to get some crypto. You still need to on-ramp somewhere. Yeah,
exactly. Yeah. But I think that problem's been solved by like centralized exchanges or like
I think
Revolut wallets.
Yeah, Revolut, sort of Coinbase, like Kraken. I don't know what's big in the US, but like in the UK, Coinbase and Kraken are the main 2 fiat on-ramping. There's WireX in Europe as well. Yeah. I still think it's a bit of a painful experience, but
it is. But we're not too focused on that part because there's a little bit too much. Once you're there, you get past the first part, like you're in Coinbase or whatever, you can access any DeFi
L1, right?
Possible.
And so like, how is it different from, so you've heard about this Ethereum, this concept of account abstraction. That's kind of a little bit what you're talking about, like having like no gas and being able to execute transactions like this. There's a little bit of this idea of account abstraction in there, right?
Yeah, I think there's a little bit. Whereas account abstraction is really based on, I mean, it's based on intents, right? Yeah. So, and we are kind of intents based because like those deposit addresses are intent based. What's the user's intent? Decode that, then execute what they want to do. So it does have similarities to that. Yeah. Are you familiar with like remittance, that sort of thing?
Yes, because so this is people working in one country and sending it back to another, right?
Yeah, exactly. And I do the same. Like my family's from the Philippines. I send back things back to the Philippines. One of the things I'm really excited about is like the ability to, let's say I have a Revolut wallet with USDC, being able to send USDC from Revolut to a deposit address, and then that being automatically converted to a stablecoin in PHP to my family back in the Philippines. And then
they don't need a Revolut wallet; they can have whatever wallet they've got on their phone, and
whatever they have. And it's essentially using DeFi as the rail, like kind of the dream we've always had, as the rails for everything. But you don't need to deal with all these wallets, this gas. It's essentially just sending. That thing as efficiently as possible.
Without like it taking 48 hours to clear, and then your bank ringing you up and going like, "Why are you sending this money?"
Paying 10% in fees. 10%
in fees. Like, oh well, you need to like show me exactly why you want to send this transaction. I totally get it, man. I totally
exactly. So overall, the idea is to really be this layer that's as easy to use, so that any DeFi protocol.
So basically, it's like Swift. You're like Swift for DeFi, like this like rails that exists between all the banking sort of like things. It's like it's those rails.
Probably not Swift. Swift is like the plumbing, maybe. Maybe it's more like Plaid.
Yeah,
if you're familiar with them, just the easiest way for any user from wherever they are to be able to use the thing that they want to use.
It is the plumbing though, right? Because don't your validator nodes like
That's
actually
true.
execute the actual like plumbing bit, which is like, hey, the plumbing here is like, I've got USDC at this address.
Yeah.
My intent is to send that to the thing that I've encoded in my address is like, when you get the USDC, you need to bridge it to this network. You need to execute a swap into PHP, and then you want to like say bridge it to this network, right? Yep. Okay, that's plumbing.
Yep, that is plumbing. Yeah, for sure. Yeah, I think like what we're really selling is kind of it's plumbing in service for the user.
Right. Okay.
In the end.
Yeah. Makes sense. That makes sense. Yeah. But it's kind of the both together, right? It's like the plumbing and the app at the same time.
Yeah. Exactly.
I didn't mean to offend you by saying it was Swift.
No.
Well, we don't really have that here though. That's more of a US thing because we've got faster payments here. I am always like shocked how crap.
Oh yeah,
finances in the US, given it's such a powerhouse in finance.
Yeah,
it's like 20. Like I don't know if you're used to it, like if you know what it's like in the UK, but like there's no like instant payment on in GBP.
Even in the Philippines, it's funny in the Philippines. Whenever I'm there, I've got an exchange in the Philippines, Coins PH.
Yeah.
When I withdraw to my bank,
we
actually got we need to do integration there for this coin that we're. A client of ours. And Coins PH. I'm like, I've never heard of it. That's cool.
Yeah, it's a Philippines.
Yeah. So are you excited about the testnet launch?
Oh yeah.
Yeah. Are you in that stage of like nervous excitement?
I mean, I'm not even sure if I'm in the excitement stage. I'm just like, there's so much shit to do.
Just tell me about it.
Get everything done, and then maybe I'll be happy later.
The thing is, I remember we were developing with 3 guys, and I'm like, we just get like one more engineer, the amount of extra stuff we're going to be able to do.
Yeah.
And of course, like you get an extra engineer and then, you do more stuff, but like you're still like completely constrained. And then you get another engineer, we're like 8 engineers now. And I'm like, we'll be able to do so much. And we're very like, we have a philosophy of like not having many meetings and, really trying to not have a lot of bullshit process in the way.
Yeah.
And still I'm like, God, I need another engineer.
Yeah. It's like the Mythical Man month.
Mythical Man month. It's exactly Mythical Man month. Yeah. I think we can draw a close. I want to say thanks and we'll see you next time.